Alrighty, welcome to week 4, day 1. Today we are going to be talking a little bit about classes. Today's lecture is going to be in Python, but the discussion that we have is applicable to JavaScript and honestly, most other scripting languages as well. So let's think about a hypothetical use case or a hypothetical scenario. Let's say that you are working for a car dealership and they want you to take note of a specific car that comes into the shop let's say it's a into the shop and they want you to note when once it gets sold. So to do that, we could probably create some variables describing the car. So we can have, let's say, like the car make. We can make that be like a Toyota. Car model is going to be a Camry. We can have a like car color is going to be like blue. Car price is going to be like $10,000. I wish that was how much a Camry cost. And then car sold can be like false or something like that. Right? That's for one car. So we have a couple variables for it. What the user can do is, you can design a function or something later that says, let's still say sell car. And then we can just say car sold is now equal to true. So if I run sell car, which a user would hypothetically want to do, then that would function to sell the car with these attributes. Okay, great. So that works for one car. Now, let's say that the dealership comes along and it's decided to double its inventory. And instead of just having one car, they now have two cars. They've got a Toyota Camry for $10,000 and a Honda Accord for $8,000 or something. And they say, we also want to track if that Honda Accord was sold too. So the easy way to do this is to copy paste everything. And we can change this car to first, here, let's do that a different way. Let's do a find and replace. Let's change this to car. We'll change it to car 1. There we go. And now we'll copy, paste that, and we'll change this to be car 2. And we'll change this to be a Honda Accord. We'll make it red. We'll make it $8,000, and it also hasn't been sold. So we've got, our two cars, for example. But is there a better way that we can do this? Is there a better way we can store this information for a single car? Because think about it. We are essentially just all of these traits, the make, the model, the color, the price, the sold, they aren't independent variables. They're all describing the same thing, just describing different facets of it. So, what are some things that we could do in order to simplify this process a little bit? Well, instead of having each of these be separate things, why don't we combine them into one variable? So what we could do is we could maybe create what could this look like? Or what does this look like? Where you have something on the left and something on the right, and something on the left and something on the right, housed in one data type. I'm trying to be vague to not give the answer away, but is there a way that we can is there a data type in Python that has a similar structure to this?
Yeah. Dictionary.
Dictionary. Perfect. Thank you, Gizem. So let's make a dictionary for this. So let's call this like the car 1 dictionary is going to be, let's say, so we can say make is going to be Toyota. And then we can say, oh, that's supposed to be in model is going to be, we can just do this exact same thing. So we can say model is going to be Camry. Um, we have color and then price. And if it's been sold, no, sold is false. Oh yeah, and then we need to change all of these to colon because they're key value pairs. All right, so this is a little bit more efficient, right? Because now we are essentially representing the car by this dictionary. So now let's say if somebody tells you, a customer walks into the dealership and they're like, hey, I'm interested in that blue Camry on the lot. How much does that blue Camry cost? Well, you know that it's in represented by this dictionary. So what you could say is car one dictionary dot price. And that will give you the price out. But again, we run into the same problem that we ran into before, where if I want to, create a brand new car, I have to go copy this and, create a brand new dictionary and copy over all of the details for it, which, is fine if you have, say, two cars or three cars. We can just keep on copy pasting that dictionary and adding in new variable names, like until the cows come home. What if your dealership decides to expand from not just one car or two cars, but by some miracle, they now end up with 35 cars on the lot that just like got dropped off because no one wants them? As a programmer, it is a terrible decision to say, all right, I'm going to go through and copy paste this dictionary 35 times and just rename it to be car 3 dict, car 4 dict, car 5 dict. We do not want to do that. That goes completely against dynamic and functional programming. It's really bad. So, how can we solve this? The answer to this crisis is a class. Or more specifically, we can call it a class object, but no one really calls it that. They'll just call it classes. So that being said, what is a class? So a class is basically a template that you can use to create multiple instances of an object. So what do I mean by instances and what do I mean by objects? In this case, a an object is a car, like a generic car. And an instance of the car would be the blue Toyota Camry that cost $10,000, or the red Honda Accord that cost $8,000, etc. Essentially, or similarly, you could have the object in question being a dog, and the instance of the dog could be, a beagle, a poodle, a 5-year-old German Shepherd, and so on and so forth. It's basically creating more specific versions of the thing described by the class. So does the purpose of classes make sense? Are there any questions about that so far? All right, so let's talk about how we actually define and use classes. So in Python, and in other languages as well, but we'll focus on Python, the way you define a class is similar to how you define a function, but slightly different. So the way you define a class is by saying class, and then we can just specify a name. So I'll call it car. And now inside of that, we are going to pass in your instance variables. So we're going to pass in your variables, or pass in is the wrong word. We're going to write down your instance variables. So let's copy paste some of these, and we'll just take out make, model, color, and price and sold. So standard practice to begin your class name. Yes. So in general, you want to begin your class names with a capital letter. And here's why. So, well, actually, we'll get to why in a second, but let me write down a reminder for myself to do. Why do class names Start with a capital letter. This is going to be important, and we'll get there. We'll get there shortly. So the way that a class works is you have three main components to a class. You have your variables, you have your instantiation method, and then you have your other methods. So what is an instantiation method or a init method? You can also call it initialization. So remember that the whole purpose of a class is to create multiple instances of an object. So from the car class, I should be able to create a object for my car, object for your car, object for random car, etc. Now we need to have a way to turn this class car into, a specific into a specific object. And that's where the initialization methods come in. That's what allows you to differentiate between the different instances of that class. So, well, I guess before we talk about instantiation methods, we should also probably talk about how to physically create an instance of the class. Now, the way we do that is here we've got our class created at the top. It has these characteristics. So let's create an instance of our car. So we're going to say car1 is going to be the car class, and then open and close parenthesis. And let's just, for good measure, let's print out car1 and see what happens. So a couple of things to point out. When we instantiate a class, we do so by saying, so new instance of class equals class name, and then opening and close parentheses, and then arguments, and we'll talk about that in a second. Now, what does this format look similar to?
Function.
Function, exactly. So going back to Sean's question, why do we capitalize class names? If we didn't capitalize class names, I could very easily have written down, oh, car like that. And now this just looks like a function, even though it's highlighted differently, thanks to the magic of VS Code. But that looks like a function. So the reason we usually capitalize our class names is because that's how we can differentiate classes from functions. It's mostly stylistic, but hopefully that helps. Okay. Let's see. What are other things that may be important? Um, not sure why that decided to run, but oh yeah, sorry. That's what I meant to do, was actually run the file. Uh, oh, it's running this in my Python terminal. That's weird. I wanted it to run in Bash. Okay, that explains why everything failed off. And okay, I'm gonna pause the recording while I look at what's done. Okay, so now that that weird issue is out of the way, let's get back to talking a little bit about classes. So something that Phyllis just mentioned is the init method. Um, as she said, the
Could you
init
turn off?
method is the oh, sorry, say that again.
Sorry, I'm unmuted. My bad.
No, you're good. Um, so the init method is the way that we run, essentially run this class, or correction, is the way that we can define an instance of this class. So if I were to just say car and then run it with the parentheses, it's going to go up and reference this init function that takes in a parameter called self. So what self lets you do is it lets you define specific things that are inherent to your class. So Here, let me see if there's a better way. There's a better way to describe this. We'll talk about class variables and then instance variables as well. So class variables are variables that are constant across all instances of the class. So for example, if I run a Honda dealership, it makes sense that the make of every car in my dealership is probably a Honda. However, every car might not be an Accord. Its color might not be red, and its price might not be $8,000. We can assume that all the cars are unsold. So class variables are variables that have the same definition across all instances of the class. Instance variables, meanwhile, are variables whose definitions are different depending on the instance. So, for example, the model of your car is probably different instance to instance. For one car, it might be a Accord. For another, it might be an Odyssey. For a third, it might be a CRV, and so on and so forth. So what we'd like to do is we'd like to have a way for the user to tell us or to tell the code, hey, just like in a function, you specify a variable, you specify an argument. We want to do the exact same thing with a initialization method. And we can do that by adding that as a field. So what we can say is, let's say, car model, and then car color, and car price. So now we can, just like in a function, we can swap out the placeholders for actual variables. So we can say that's car model, this is going to be car color, and this is going to be car price. However, this will not work. This will not successfully create a specific model, color, and price for our car instance. And the reason for that is because of this little keyword called self. What we need to do is add self dot to the start of each of the variable names that we create here. And the reason for that is, again, because we are creating an instance variable. So because the definition of, say, model is different every time I create this class, by saying self dot, we are telling Python, hey, I want you to define the model of my car as whatever model it is. However, I only want you to define that for this instance of this class, for myself, essentially. I don't want you to carry over that definition to every single other class object, just this one. And that's why the self part is very important in that init function. Does that make sense? Any questions about that so far? Okay, so let's see an example of this in practice. So let's create a brand new car. So first we're gonna run this and see what happens. Because like I said, you should be able to create a car by just putting parentheses in. Now, okay, that was a bit of a misnomer. You need to be able to, you need to, when you instantiate a new instance of a class, you have to put in arguments. Now, what arguments would you put in? The arguments to your initialization function. So let's create a car whose model is a Accord that is green and that costs, I'm just typing random numbers. And let's print this out and let's see what we get. So I didn't get any errors, but I get something kind of weird down here. It says main car object at some weird number. Let's break that down. The first thing that it's doing is it's saying we have the thing that I'm accessing is a car object. It's not an integer, it's not a string, it's not a Boolean. No, this is something of type car. Python does not know any more than that about it right now. And in a future lecture, we will talk about how to tell Python what things are going on. with that specific instance of your class. Next part is this at 0x dot 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 dot. Can anyone tell me what this might be? And the 0x is going to be your biggest hint.
A location.
A location. Okay. That's a good start. Any idea what type of location or where it's pointing to?
Hamilton typed in memory.
Oh, thank you for catching my yes. Yeah, in memory is correct. Nice work, Hamilton, and Kim, thank you for catching that. But in general, if you see something with a 0x at the start of it, anywhere in programming, that is a number in hexadecimal, which is base 16. And generally, if you see something in hexadecimal, that most of the time means that you're looking for something in memory. So what the output of our print statement is doing is it's saying, here's the type of thing it is, and here's where it's located. Now, that doesn't mean that the thing we printed out is our car object. That's not correct. All we're doing with that print statement is Python is giving us the most bare bones description of what the thing we told it to print is. Now, here's what we can let's play with this a little bit more. So, like I mentioned, the benefit of creating classes is we can access things within that class. So let's say again that someone walks up to the dealership and they're like, "Hey, you have a Honda Accord sitting on the lot. I want to buy. How much does that Honda Accord cost?" Well, what we can do is we can access the instance of that class and then hit dot and then look at the variables and we can say dot price. Now, you'll notice the syntax of this looks pretty similar to the syntax of accessing something within a dictionary. And you'd be right. It's very similar syntax. Because what you're doing is you're saying, here is the object that in this case is your class, and here is the name of the variable that I want within that class. So by printing out car1.price, we see that the price is a bit over $12,000. Now, what I can also do is I can create a second car. Now let's do the exact same thing. Let's create another car. Let's call this car 2. Let's make this a one that's easier to spell. I'll say a CRV because my brain's forgetting how to spell the word Odyssey right now. Let's make this purple and let's make this $22,000. So if we print out car 2, remember that car 1 and car 2 are different objects. So if we print them out and we take a look, they print out almost the same thing. They're both still car objects, right? They're both types of cars. However, if you take a look at the numbers in hexadecimal, they're very slightly different. One of them ends in an FD0. The other one ends in an F10. What does that mean? The fact that those numbers are different is telling you that they live in different places in memory, which means they are fundamentally two different objects. However, they are both still instances of the car object. So these are different cars. Again, that's another benefit of classes is we don't have to copy paste and retype all the variables every time we want to make a new one. All I need to do is just basically write one line. Say, I want to create a new car. It's a car. Here are the things I want to do. I don't need to go and do what we did earlier and copy paste every single thing. So that's really one of the main benefits of classes. Now also, let's go to talking about those class versus instance attributes. Right, so I mentioned that instance attributes are different or instance variables. Here, we'll call them attributes because that's what they're actually called. Instance attributes should be different for every single instance of that class. So, for example, we can print out the price of car 2, and the price of car 2 is $22,000, which is different from the price of the instance of car 1, which is about $12,000. But both of these cars should still be Hondas. Why? Because that's what we specified up in the class attribute section, where we said these variables have the same definition across all instances of the class. So why don't we check that? So we can print out car1 dot make, and we can also print out car2 dot make. Let's run that, and we see that indeed both of those are Hondas. And note that we never set in our initial call to that initialization function, we never said that car2 was a Honda. But because we defined that up in the class attributes section, it automatically knows that it's a Honda. Well, because we told it so back when we designed the class. So that is a very rough summary of what we can do with what classes are, what types of variables or what types of attributes lie within classes, and how to create your own. Does that make sense? Does anyone have questions about classes so far? All right, fantastic. So what I would like to do is, oh, why don't we try an example together? So I would like, let's say that I am now working, you end up getting paid by the car dealership for making this class, and then somehow the same guys who run the car dealership also decided to start a bookstore. They're very diversified economically, or so it appears. And they now decide, because you did such a great job with that car class, to make a class for the bookstore. So let's make a book class. What things should our book class include? What are things that books have?
Titles,
Okay. So here, let's start.
genres,
Fiction, nonfiction.
Okay. So let's assume that all of that this bookstore only sells fantasy novels. What other things do books usually have?
authors,
Author. Yeah, let's assume it's one author. Um, say maybe the number of pages. It's probably good enough for now. So that's 4 different attributes that our class is going to have. Now, based on what we talked about, if I have a series of 4 variables, title, genre, author, pages, which of those are going to be class attributes and which of those are going to be instance attributes?
genre would be the class attributes, and all the other ones would be variables.
Yep. So what we could do is we can say here that genre is going to be fantasy. And then for everything else, we can define our init function. And then we add in our little input. So we say title, author, pages. And then how do we take things from that init function and turn those into instance attributes?
Self.title equals title.
Perfect. We have self.title equals title. Now, why can't I just say title equals title?
Because each one has a different one. Oh, yeah.
This. And
Each
that's
one-
where the self. So we can do the same thing, self.author, self.pages equals pages. Also, in general, when you're writing the init function in Python, or really in any language, but in general, it is decent practice to have, unless you need to change it, you have the argument name of your init function be the same thing as your instance variable name. That's just good practice to have overall when you're writing functions for classes or init functions for classes. Though there may be a case where there may be cases where you don't want that. So for example, let's say that your bookstore gives every book under $5 a special red sticker. So that way people know that it's reduced price. So we have a red sticker. However, that red sticker is going to be price dependent. So when I'm cataloging a book, I don't necessarily know right away if it needs a sticker on it or not. What I do know is the price of the book. I can put the price of the book in. And now what I can say, or ask myself, is I can say if price is less than or equal to 5, then we have self.redSticker is true. Else self.redSticker is false. So this is a example of a case where your init function may take in some input that does not directly become a instance attribute. However, it is used to create a new instance attribute based on that. Okay, cool. So it looks like you guys have the hang of classes so far. And this is the extent that we're going to cover classes today. Tomorrow you guys are going to jump into a lot more depth on writing functions and different types of variables and all sorts of good stuff. So before we jump into problems, are there any questions about any of the foundational attributes of classes that we talked about so far?
Does the function always have to be called init?
Yes. So the init function is called init sort of as that's the way that Python chooses to describe an initialization function for a class. So the way that we describe classes in Python is going to be class name, and then you're going to have class variable or class attribute equals, whatever it is. You put your class attributes go here. Then you're going to have your init function, and then you're going to have self, and then your arguments, and then you're going to have your self dot instance attribute is going to equal, instance, or you're just going, is going to equal whatever your argument is. This is the general way that we describe all classes.
Okay, thanks.
Sean, can you explain what a dunder function is? I will be hesitant to do that right now because that will be explained in a couple of classes. What I will say though, and thank you for bringing this up, is the init function is a special type of function that Python has. You can tell that because it has these weird 2 underscores at the start and 2 underscores at the end. What that means is that it's called a dunder method. Other dunder methods exist that you'll talk about later. Like, for example, how do we turn this main.car object at 0x blah, blah, blah into like a nice little string? So that way it's not outputting a memory address, but it's outputting a description of the class. Or how can I tell if one car is greater than or less than the other? Basically, think of very basic types of functions that you might want to do with a class. That's roughly speaking for now what a dunder method is. You can have a dunder method for creating your class. You can have one for turning your class into a string. You can have one for comparing class objects to each other, etc. But more to come on that in a couple lectures.
I do have a question on the red sticker scenario you did. So red sticker hadn't been initiated anywhere. Can you just make new things up on the fly like that? And it's as much as you want to?
So what do you mean by it not being instantiated anywhere?
Like, you've got title, author, pages. It's also up in the parentheses, and then red sticker isn't. So that's my question. You can just make different ones as you go if you need to.
Yeah, pretty much. So it's not necessary for your instance attributes to always be inputs directly into the init method or into the class. You are totally allowed to create them sort of, as you said, like on the fly or as you go. That's not standard, but you can. And I mean, in a case like this, what you could do here, if you can say self.price is price, and then you can change this to say, you can keep it as price, or you can change it to self.price is less than or equal to 5. That's fine too. But you can create it as you need to.
It's as long as you're instantiating that variable within the init method, right? So you can use it later on.
Yes, that's correct. And again, we will talk about creating functions within classes tomorrow and Thursday. So it will get more complicated. But for now, as long as if you do it this way within the init method, you are creating a brand new instance variable within your class. Other questions? All right.
Definition function, it doesn't have to have a pass or return at the end. Is it because it's inside that class, or is it because like this is just a special function? Like initialization?
A mix of both. So the initialization function, it does not need to return anything. So what happens when, let's go up to that car example.
But you don't need to use the pass either, like it's fine. So any function inside the class doesn't need to use the pass then?
So you do need to use the pass if you don't want the initialization method to do anything. So every class needs to have a initialization method. And this was something that Phyllis alluded to earlier. But whenever you define a class, it has to have an initialization method. Now, let's say that you are defining something that doesn't have any instance attributes. So you never need to do the self-instance attribute thing. And it doesn't take in any arguments. So arguments don't exist, and you don't have any instance attributes. You still need to have a pass in there, because if I don't have a pass, you'll see here that it gives me a little red line, and it's because you can't define a function without having it do something. And in this case, doing nothing, which is what pass does, is effectively the same thing as doing nothing. Does that make sense?
Yeah, sure.
Yeah, I've only ever used pass if I'm trying to test my code, but I know I'm going to make something like a function or a class, but I still need to test my code to figure out if it's working. And then I take pass away and put my code inside class name or function.
Yeah, pass basically just acts as a placeholder that doesn't break the syntax of your code, is the way I like to think of it. All right, so mini quiz time. Can somebody describe why, or tell me, in your opinion, why would we use classes? What are they useful for? Just in general.
It's like a blueprint. So if you wanted to customize, like, let's say cars, right? So if you wanted to customize a bunch of different cars, you could paint the car a different color. You could have the doors be differently shaped. It just allows you to have like everything that you would need to make a car, but then you can customize it.
Perfect. Thank you, Megan. That's a really good explanation. And then speaking of customizing, what's the difference between a class variable and an instance variable?
Class variables are the ones that will always have the same value, or instance variables, you're passing them into the class in order to create that blueprint, basically.
Perfect. All right, good. So let's say that I am creating a class for apples. And yeah, let's say I'm doing that. Now, if I were to create a variable representing the core of the apple, is that something that would be a class variable or a class attribute or an instance attribute?
Probably class
Class
because
attribute.
it's always the same.
Yeah, every apple has a core. So that's going to be a class attribute. But what about the type of apple? Like if it's Gala or Fiji or something like that. Would that be a class attribute or an instance attribute?
Instance.
Instance. Perfect. Yep, because again, I think as Sean alluded to, instance attributes are can be, they don't always have to be, but they can be different every time you make the class. Class attributes in general are supposed to be the same for all instances of that class. All right. I mean, I think those are really the main things to know. But the last one again being having that make sure that when you create an instance method or an initialization method, sorry, you include self in the parameters of that function. And whenever you create a new instance variable or a new instance attribute, you do self dot the name of that instance attribute. But yeah, otherwise, I think that's really about it for lecture this evening.